Assalamu alaikum dear students, hope all of you are fine. Today we are going to discuss velocity time graph, which is again the topic of AS Physics 9702, and you know that this is chapter number 2, Kinematics. So basically last discussions of chapter number 2 we had, and this is the continuation of the chapter number 2, you can say. So here we have the topic of velocity time graph. We have discussed already distance time graph in our previous lecture. So if you are following my YouTube channel, so you can go back to go through that discussion or lecture of displacement time graph. Today we have this topic, velocity time graph. Here, when you will discuss two things will come forward. One is the concept of the displacement d or s, which is basically v into t. So it means that if you have velocity time graph, then when you will multiply the value of velocity and time, basically you will get the area under the curve, under the graph. So it means that wherever you will find the area under the graph, this will give you the displacement, which is nothing but mathematically you can write in this way, that s is equal to v into t. V into t is the basic concept, but according to the shape of the graph, of course, this equation will change a little bit. But the basic point to remember is that area under Vt graph gives displacement. On the other hand, when you will consider the definition of acceleration, then acceleration is nothing but v minus u divided by t, yani rate of change of velocity, or simply you can say that the gradient of Vt graph will give us the acceleration. So this is what we have. If you will concentrate on the given graph, then you will see that from suppose time 0 to time t1, we have the slope in this way that the line is increasing. This is basically the line. So the line is increasing with the time, and the slope of the line is increasing, means the gradient of the line increasing means the acceleration we have, or at each and every point the body is accelerating. Increasing acceleration means the acceleration is not uniform or non-uniform in this area. So non-uniform acceleration. Remember this point, that whenever a body will start moving, always initially the acceleration will not constant, or velocity will not constant. So slowly and gradually, first the acceleration will increase. Suppose up to point A, this is happening, and up to time t1. So here you have the situation of increasing acceleration, yani non-uniform acceleration. But from A to B, what is the situation in between time t1 and t2? So as the velocity time graph, we have just discussed that the gradient is giving you the acceleration. In this region, the gradient is constant, so acceleration is constant. After point B, you can very easily see here that the gradient is decreasing, and at one point, suppose from point B to point C, this is happening, and simply you can say that as the gradient is decreasing, and gradient is nothing but acceleration, so simply you can say that decreasing acceleration we have. The gradient is the acceleration, and as the gradient is decreasing, so you can say there's a decreasing acceleration. But remember this thing, that still you have the positive velocity, and velocity has not changed the direction, but you are starting, for suppose, from point O. The car moves from point O to point A with the non-uniform acceleration. Then from point A to B, the car, suppose, is moving with a constant acceleration. Then you will, if you want to stop the body, slowly and gradually you are applying the brake, and the deceleration or decreasing acceleration is taking place over here. And simply you can say that decreasing acceleration is leading again towards the situation of not deceleration. Remember this thing, this is decreasing acceleration. So from point C to D, again we have a constant velocity. So here we have non-uniform acceleration, then here we have constant acceleration. From B to C, this is the situation we have decreasing acceleration, and then again from C to D we have this situation, that the constant velocity we have. Constant velocity doesn't mean the body has stopped. The body is still moving between point C and D, but the velocity is constant. So this is very, very important to understand, that what is the situation over here, and in different regions how the acceleration or the acceleration is increasing or acceleration is decreasing, or we have the constant velocity. So this is something which is very important to understand. Now here you can see another set of graphs which will help you to understand what is going on. Here if you have the speed time graph, so you can say and see that here the gradient is constant. The body is speeding, means the velocity is speeding, or the speed is increasing with passage of time, but the gradient is constant. Gradient is nothing but acceleration, so acceleration is constant in this case. Here when you will come to the second graph, you will say that the velocity is constant, and velocity constant means that the body is moving with the steady speed. But what you will say about the acceleration, so in this case, as there is no change in the velocity throughout, the velocity is same, so A is equal to V minus U divided by T if you are applying, and your V and U are same or equal to each other, so 0 divided by T you can write, or acceleration will be 0. On the other hand, if you will go to this third graph, then you will see that in this case what is happening, the velocity is magnitude or speed magnitude is decreasing, or speed is decreasing. So speed is decreasing means that the value of u is greater, but the value of v is lesser somewhere here. And when you will get the gradient a is equal to v minus u divided by t you have, so the a will be negative this time, yani negative value you will have, and this shows that the decelerating, the body is decelerating, or deceleration is taking place. So these three graphs are also very important. Speed time graphs are very useful for examining motion. They give a visual indication of how objects are moving. Yani basically, if you want to describe the motion, then these graphs will give you help to find out that particular situation. And here, as we have just mentioned, that acceleration in this case v minus u divided by t, the v value is positive value, so simple thing is that the acceleration is taking place. So this is something which is important. You can understand these graphs very easily, but you have to remember that gradient is nothing but the acceleration, and the area under the graph will give you the displacement. So here we have another set of graphs to explain these situations, like one of the graph or first graph, you can say velocity time graph we have here. In this case, you can say and see that at time t is equal to 0, the velocity is 5 meter per second, and if you want to get the value of the displacement, then simply the area under the curve, which is nothing but simple area of the rectangle, or simply you can say that this is v into t. So 5 into 5 is giving you the simple value of the displacement, which is 25. On the other hand, if you are interested to know the acceleration, then again, as we have just discussed, that in this case, as v and u are same, yani if you are just taking all these values, so all these values are same, so between any 2 points you have 5 and 5, the result is 0. So ultimately you can say that the acceleration is 0 as far as this graph is concerned. So the graph 1 is showing you that the body is moving with a constant velocity with 0 acceleration, and in 5 seconds the displacement is simply 25 meter. So this is how you can calculate the displacement and acceleration. When you will come to graph 2, you will see that here we have a situation that with the passage of time, your velocity or your speed basically is a velocity time graph. So velocity is increasing. So what we can say that the velocity is increasing. So acceleration of the body we can consider here. The main thing is that you are considering displacement, and how you will calculate the displacement, area under the curve. So here you have the triangle. So simply you can say that it is half base into height. So you can say that this is the situation of your the values. Here you have the value of your height. This is the base you have. So simply half 50 into 5, you are getting 125. So the distance covered in this diagram or in this graph is 125. On the other hand, if you want to find out the acceleration, then acceleration is very simple. V minus u divided by t. You have already discussed this formula. So this is the line you have, and the gradient is constant throughout. But what is the gradient? This is the acceleration, and here you have the situation. 50 is the value of the final velocity, and of course the initial velocity is 0 here. So when you will calculate, you will get the value of 10 meter per second square. So simple thing is that here you have the constant acceleration of 10 meter per second square. Now when you will come to graph 3, it's very simple again. Here you have the velocity, initial velocity is 50, and after 5 seconds you have velocity which is nothing but equal to 0. This is the situation here. So you can say that v is equal to 0 meter per second in this case, and u is equal to 50 meter per second in this case. As far as the area is concerned, again we have the same situation, yani the average displaced velocity you can take as 50 plus 0 divided by 2, or area under the curve again you can consider half into b into h. So this is how you are getting the displacement. And remember this thing, that the average velocity in this case, or even in this case, you can consider, because the average velocity, as we have this situation the same as here which we have just discussed. So the average velocity means that throughout your body is not moving with the same velocity. So of course, how you can get the average velocity, the initial velocity plus final velocity divided by 2, and ultimately you are getting this 125. Here you can actually relate this equation with this particular area under the graph concept, and from where we are getting this half. So simply you can say that half is actually showing here that the average velocity we are considering. So whatever the initial velocity we have, we are taking half of that value. So this is very important. As very simply, you can also describe the acceleration, or you can also find the acceleration in this case. What is happening? Initial velocity is greater, final velocity is lesser, yani 0. So ultimately you can say that you have 0 minus 50 divided by 5 seconds, and we are getting minus 10 meter per second square. So this is nothing but the deceleration. Any body is decelerating, and simply you can say that the velocity is decreasing with the passage of time, and the deceleration is taking place in the body. And what is the value here? 10 meter per second square. So here we have the situation of acceleration, constant acceleration you can say, not increasing acceleration as we have discussed in the previous case. This is acceleration, and this is a deceleration, not decreasing acceleration. Decreasing acceleration is something different, and deceleration is something different. I think the most important graph is this one, which will explain number of things. With the fourth graph, where you can say and see that the initial velocity is 30 meter per second, and from this you are going, of course, in a particular direction. And what has happened? The time has passed 3 seconds, and at 3 seconds you find that the velocity becomes 0. After 3 seconds up to 5 seconds, the velocity is increasing on the negative side. So remember this point, that this situation is very, very important. The negative velocity is increasing. Here the positive velocity is decreasing. So positive velocity is decreasing from point A to B, means the deceleration is taking place between point A and B. But at B, actually what has happened physically, you can say that from point A to point B, the velocity is in this direction, and the velocity is decreasing. But at point B, the car, suppose, or the body, the body in the motion is taking a turn and going back in the opposite direction. So from B to C, you have this situation, that over here, for this situation, you can say that the velocity, initial velocity at this point for the new direction, you can say is 0, and here you have the final velocity. So this is how you can write. So simple thing you can say is that the acceleration is taking place in the opposite direction. So this is very, very important. Here we have this situation that A is A is equal to V minus U divided by T. So minus 20 you have here, and this is your, of course, 0 initial velocity, V minus U. So initial velocity is 0, final velocity is minus 20. So here you are getting minus 10 meter per second square. But remember this thing, that this minus 10 meter per second square and this minus 10 meter per second square is not giving you the same information. This minus is telling you the acceleration in the opposite direction, and this minus is showing you the decrease in the velocity. So this is very, very important, that when you will draw the acceleration time graph, you have to consider all these facts. Like here, suppose you have a situation, you are drawing a line which shows that no acceleration or 0 acceleration. This is how you can write 0 acceleration. Yani the velocity was constant and 0 acceleration we have. This second part shows the acceleration over here, and this is positive. So what is happening? The velocity time graph is basically something like this. Velocity time graph is a straight line, so you can say as the slope is constant, so simply you can say that the acceleration is constant. You know that the gradient of this line or this graph is the acceleration, and which acceleration? Of course, constant acceleration. And there is another thing which is very important. This acceleration is also constant but zero. This acceleration is also constant but has a value. So like suppose this is 10 meter per second square. So be careful of this fact that here we have this situation. On the other hand, if of course you have the velocity time graph which is starting from a higher value, and you can say that something like this we have. So what is happening in this case? So simply you can say that the acceleration value is negative. So this is what we have. So this is basically the deceleration. This is basically velocity time graph which we have discussed previously. Velocity time graph. So in this case what is happening? The acceleration is taking place. In this case what is happening? The deceleration we have, and then of course we have to show the deceleration on the negative side. But this is the most important graph, and this is the fourth graph which we have discussed as far as the velocity time graph is concerned. We have just discussed that if we have a situation like this, so we have just discussed that the graph is something like this. So what is actually happening in this case? From point A to point B, we have the negative gradient. Even from point B to point C, we have negative gradient. But remember this thing, that the negative velocity is increasing from B to C. From A to B, positive value, yani suppose we have taken value as 30. So suppose from 30 meter per second, of course this is your velocity time graph again. So from 30 to 0, so this is basically the deceleration. Here you have this region from A to B, and as I said that the gradient is negative, but this negative is actually showing the decrease in velocity. So this acceleration, which is negative acceleration, is showing you the deceleration. Be careful. But on the other hand, if you will go from B to C, still you are getting the same gradient, yani negative gradient, but this time you know that the negative velocity, yani velocity value is increasing but in opposite direction. Negative velocity is very important to understand. Negative velocity means the not the decrease in velocity, but the direction is also indicated by the negative sign. So here what you are saying, that from B to C what is happening, the you can say the negative velocity is increasing. So here this negative acceleration from area or from point B to C is showing you that you are getting acceleration in opposite direction. So this is very important graph. This is the most important graph I can say, because if you are drawing a curve like this, here you have a situation where one part of the graph is showing you the deceleration, the other part of the graph is showing you the acceleration, but overall if you will see, the sign of acceleration is negative. So there should not be any confusion with the sign of the graph. So this is very important point, that here we have to understand that what is the situation. Let me show you one thing here, which is basically the graphs, how you can deal with the graphs and what graphs are showing you. Here we have this situation, like here you have velocity time graph, and you have, like here you have the velocity time graph. So this velocity time graph, you can use this animation, you can use to get what is going on. And even here you can change the position. Yani if you are suppose changing the position here, then you can see what is going on as far as the displacement at the top and the acceleration is concerned is changing. If you will change the value over here, then you will see that the value of the displacement is different, and here you have the situation of the displacement and acceleration again. So by easily changing the positions of these points, you can say that what is happening in one case or the other. I just want to show you another graph which is basically showing you the graph which we have just discussed. In this case, if you are changing the position of your velocity, like suppose here you have this value, positive value of your here you have this situation, then you can see that how the displacement and the acceleration of the body is changing. So from say I am just concentrating on the velocity time graph. So from the first point somewhere here to this one, you can say that the body is accelerating. So here you are showing this acceleration, positive acceleration. But from this point to this point, you can say that we have a decrease in acceleration, decrease in velocity, not in the acceleration. Yani apparently the velocity is decreasing, but as I have already explained to you that from this point you can say to this point, or even somewhere here at point 0, the velocity I can take suppose this point here and this point somewhere here. So this is actually I want to show you that the point V to this point the velocity is increasing, so acceleration is positive. Then from this point to this point the velocity is decreasing in one direction, so the part of the acceleration over here will show you this particular situation. Then from this point, from this point to this point, you can say that the velocity has increased on the negative side. So again you can say and see that the part of the graph on the acceleration side is negative, but as I have already explained that this negative, the next part of the acceleration is nothing but the acceleration on the negative side. And here you can see that when the body is moving, or the graph V is moving from this point somewhere here, so you can say that the change again is that the first of all you can simply say that the negative velocity is decreasing, and then we are going toward the positive side. So all the value of your here we are, here we are. So for this point to this point you have the positive acceleration, but remember this thing that positive acceleration is only half of the graph, you can say. As far as this situation is concerned, this is very important that the positive acceleration, where is the positive acceleration and where is the negative acceleration. So from this point to this point you have to consider the situation of your acceleration, which is somewhere here at the top of acceleration time graph. So this is something which is very important to understand, that how we can see the variation of position time graph with the velocity time graph and acceleration time graph. So this is very important to understand that we have these different situations. So for the time being, I am just stopping the discussion here, hoping that you have developed some understanding of acceleration time graph, velocity time graph, and the different situations of the velocity time graphs. So these are few things which we have discussed today, and then inshallah in the next class we will discuss again another actually lecture we have to take for the motion graphs. So till the next lecture, Allah Hafiz, take care. If you are new on my channel, then subscribe this channel and press the bell icon and like and share with your friends, so new students and more students can get benefit of these lectures. Till the next lecture, Allah Hafiz, take care.